When you think of space, apart from the massive inky blackness and emptiness, you also think of other planets. As we are currently all still stuck here on Earth, there are so many great and unanswered questions that we could ask. And one of the most burning ones is the question of whether there is life on other planets, and if indeed there are other planets with similar conditions to Earth. The Alpha Centauri system is the closest to our own, being just 4 light-years away, and could even have an Earth-style planet in orbit around the stars. So let's take a look and ask, how would an Earth-like planet look in Alpha Centauri? As we know, the closest stars to our own Sun are the 3 stars of the Alpha Centauri system. As they are just 4 light-years away, we have come to know quite a bit about this system. The nearest of the 3 stars is a red dwarf called Proxima, which has 2 known planets. However, the other Sun-like stars in the system, Alpha Centauri A and B respectively, have no known planets. But that doesn't mean they're not out there. As a matter of fact, astronomers have made a pretty big leap lately, imagining a yet-to-be-discovered world that could well exist in our neighboring system. By using a new computer model, all information that is known about Alpha Centauri can be run and extrapolated, generating a set of characteristics of a possible world that could be in orbit around A or B. The hypothetical planet is called Alpha Cen Earth, but it could be much more than a hypothesis. A recent study by researchers at ETH Zurich in Switzerland was published in the Astrophysical Journal and explains their findings in detail. Alpha Centauri A and B are an interesting pair, both orbiting each other closely, while Proxima orbits them much further away. They lie an average of 23 astronomical units apart, which is just a bit more than the distance between our Sun and Uranus. And that means that the conditions could be right for a planet just like ours. At the moment, it's hard to say anything completely concrete, because the planet is still only hypothetical, but the hypothesis is based on everything we know about the 2 stars Alpha Centauri A and B, which is quite a lot. Astronomers have then been able to project that a rocky planet, much like Earth, could exist, as well as what it might look like and how it could have been formed. The ETH astrophysicist Hyung Wang led the team researching this hypothetical planet, and the team calculated the composition of such a world in what's known as the habitable zone of Alpha A and B. This would be the region of the star system where conditions are suitable for water to exist in liquid form. It is interesting because the 2 stars orbit one another so closely. Using what we know about the chemical compositions of Alpha Centauri, scientists have extrapolated the composition of a rocky planet in such a habitable zone and found that it made sense because both stars, as well as any actual currently unknown planets, would have formed from one primordial cloud of dust and gas. This means that expected elements in such a hypothetical world would be rock-forming elements like iron, silicon, and magnesium, as well as volatiles such as carbon, hydrogen, and oxygen. With elements like these making up such a world, it is easy to start forming your own ideas about what kind of world it is. But of course, this is still just conjecture, and the study does not definitively say what it would be like to live on a planet in Alpha Centauri, because it cannot, of course. Still, it's quite an impressive model, and it gives us a lot of ideas about what might be out there. The burning question that's probably forming in your mind then is the big one. Is there life out there besides ours on Earth? Well, that's highly likely, statistically speaking, as the universe is vast beyond any and all knowledge and human experience, and if you increase the range wide enough, the chances of finding anything dramatically increase. As for Alpha Centauri, if there is truly a rocky planet there, then it would likely be extremely similar to our own Sol 3, or Earth, in terms of geochemistry. The researchers who conducted the study also said that their model showed how this world would most likely have a mantle that is enriched in carbon-bearing sorts of minerals like graphite and diamond and would be riddled with silicates. That would be an efficient mantle when it comes to storing water, in much the same way as the mantle of this planet does. As you should probably expect, Alpha Cen Earth would be a brother of sorts to our own planet, but it would absolutely not be a perfect twin. For starters, the geography would be vastly different, but beyond that, from a scientific perspective. Its location would provide different results. It would possibly have a fairly large iron core, far lower geological activity, and no plate tectonics to speak of. However, it has been said that the planet's early atmosphere would likely resemble the Earth's early atmosphere. This means that it should absolutely have an abundance of carbon dioxide, as well as methane and good old H2O. That all sounds so far so good, right? Well, there's a bit more that goes into a planet being able to sustain life. A part of the study says that the primitive mantle of this model planet is considerably more reduced, by 2 orders of magnitude, than that of Earth. It is also modeled to be relatively enriched in graphite or diamond. This should hold even if some portion of native carbon species has been segregated into the core. Together, these factors preferentially impose a stagnant lid tectonic regime. That means that we don't know yet how a planet with no tectonic activity might be able to sustain life, when we also suppose that plate tectonics were an important player in the habitability of Earth. There's another factor too, and that is that Alpha Centauri is about 1.5 to 2 billion years older than our own solar system. That means, while we're speculating about there being life on this new planet, the reality is that such a planet would be much, much older than Earth, giving life far more time to evolve, barring some kind of planetary cataclysm. The study is unlike many other studies, in that it focuses largely on the volatile elements on the hypothetical planet. Rocky planets like ours tend to share the chemical makeups of the host stars. That means that yes, we can tell the refractory elements, like rock and metal, could be suitable, but the volatile elements are the ones that decide if someone can go and live there. But the fact this study has happened now is a happy piece of luck, as now is a wonderful time to begin searching for this kind of planet in Alpha Centauri. At the moment, you see, and from now until 2035, the 2 stars, A and B, will be far enough apart from each other in their binary orbit that we will have a much easier time detecting planets that are orbiting them. This means that we are in the lucky position of having the right equipment, the right technological ability, the right knowledge, and the right timing for the next 13 years or so to see if we can find any planets like our own. That's an incredibly amazing thing to be able to do, and the next few years will give us our best opportunity to confirm the presence of planets, or of course, the lack of any. Of course, in the meantime, keep in mind that astronomers have already found over 5,000 exoplanets, meaning worlds outside our solar system, all orbiting far off distant stars. This is one of the reasons that we are looking at Alpha Centauri, because it is so close by, and since we have already found the existence of worlds further out, conventional logic would presuppose the existence of worlds much closer that we have just missed or overlooked. The bottom line is that as we continue to explore all these places, it becomes more and more likely that we will eventually encounter a world like our own, with the right combination of elements, the right proximity to and from a star, and the right terrestrial circumstances to support life. But will that life be similar to ours, or a variation? Could there even be another human race out there somewhere, asking all the same questions that we are? This study helps us a lot towards figuring out that answer. But what do you think? Comment down below. And for more space tales, like this video and subscribe to Space Infinity.